Hello class, this is lesson 2-4 about solving equations with variables on each side of the equation. So the first step that you want to do is get rid of any parentheses that you have in your equation. And you would just do this using the distributive property to get rid of that outside number. And then your second step after that is going to be simply to just combine any like terms that you have on the same side of an equal sign. Now, it's not always the case, but this is what I would recommend for your second step. For your third step now is I want you to move the variables to the same side. And so what I like to do is I like to typically move these to the left side, and you do that by either adding or subtracting on both sides. Once you have the variables combined, then you can go ahead and move that lonely number to the opposite side. We want to move it away from the variable. So this might be the right side. And you're going to do this again by adding or subtracting. And then your final step is to just get rid of that leech. So that number that is attached to the variable, and that's by either multiplying or dividing. So let's go ahead and do it. 5 plus 7a equals 4a minus 13. I have no parentheses, so let's move the variables both to the left. So I'm going to subtract 4a on both sides, which leaves me with 5 plus 3a is equal to negative 13. Now I'm going to move the lonely number to the opposite side, so I'm going to subtract 5 on both sides, and then I'm left with 3a is equal to negative 18. Final step. Let's get rid of the leech. So let's divide both sides by 3, and I find that a is equal to negative 6. Like we've done before, let's just plug this in and check to see if we got the correct solution. So 5 plus 7 times negative 6, is that equal to 4 times negative 6 minus 13? So this is 5 minus 42, and that is negative 24 minus 13. 5 minus 42 is negative 37, and when I combine the numbers on the right, they are also negative 37. So I'm correct. Let's move on. 5 minus 13c is equal to 4c plus 39. Since there's no parentheses, let's subtract 4c on both sides to move the variables to the left. I'm left with 5 minus 17c is equal to 39. And now I can subtract 5 on both sides to move that lonely number to the opposite side. When I do that, I'm left with negative 17c is equal to 34. Final step, let's divide both sides by negative 17 to get rid of that leech. And I find that c is equal to negative 2. All right, let's go ahead and plug this in and see if we got the correct solution. So 5 minus 13 times negative 2, is that equal to 4 times negative 2 plus 39? So let's do some math. That's positive 26, and that's negative 8. So 5 plus 26 is 31, and negative 8 plus 39 is also 31. So my solution worked out. Now our next two examples have parentheses in them, so let's use the distributive property. 7 times n is 7n, and 7 times negative 1 is negative 7. Negative 2 times 3 is negative 6, and negative 2 times n is negative 2n. Now I can go ahead and move the variables to the left-hand side, so I'm going to add 2n to both sides. That leaves me with 9n minus 7 is equal to negative 6. Then let's add 7 to both sides. That leaves me with 9n is equal to 1. And now when I divide both sides by 9 to get the n alone, I find that my final answer is 1/9. So it seems odd that I have a fraction, but let's plug it in to check it out. So I'm going to plug in the 1/9 into my original equation. 1/9 minus 1 is negative 8/9, and that's going to be multiplied by 7. And 3 plus 1/9 is really 3 plus 1/9, And if I'm going to rewrite that as an improper fraction, that would be 28 over 9. So now we just multiply. 7 times negative 8 is negative 56 over 9. And negative 2 times 28 is also negative 56 over 9. So my solution worked out. All right, let's do this again. Let's get rid of our parentheses. So I have 7 is equal to negative 11 plus 3b plus 15. Now, if you notice, I have two lonely numbers on the same side, so let's just put them together. 7 is equal to 4 plus 3b, and now all I need to do is move that 4 to the opposite side. So I'm left with 3 is equal to 3b. Final step, let's divide both sides by 3, and I find that my final solution, b, is equal to 1. All right, let's go ahead and plug this in. 7 is equal to negative 11 plus 3 times 1 plus 5. And 1 plus 5 is what we're going to do first. That is 6. And then, according to PEMDAS, 3 times 6 is 18. And negative 11 plus 18 is 7. So my solution worked out. Now you see that we have one side where there's an expression divided by a number. So the first thing that we want to do is to get rid of that denominator. So in order to do that, I'm going to multiply both sides by 4, which is the denominator. That leaves me with 20y on the left, and then just the numerator, 12y plus 16 on the right. Now I can go ahead and subtract 12y on both sides to move the variables to the left. And then that leaves me with 8y is equal to 16. Final step, let's divide both sides by 8. And I find that y is equal to 2. All right, let's go ahead and plug it in and check it out. So 5 times 2, does that equal 12 times 2 plus 16 divided by 4? So that leaves me with 10 is equal to 24 plus 16 over 4. 24 plus 16 is 40, and 40 divided by 4 is 10. So again, my solution worked. All right, let's do this one more time. Let's multiply both sides by 5, which is the denominator, and that leaves me with 6x minus 9 is equal to 15x. Now I can subtract 6x on both sides to move the variables to the same side. That leaves me with negative 9 is equal to 9x. Divide both sides by 9, and I find my solution x is equal to negative 1. All right, let's go ahead and plug this in one final time. 6 times negative 1 minus 9 divided by 5, is that equal to 3 times negative 1? So that is negative 6 minus 9 on the top. Negative 6 minus 9 is negative 15, and that divided by 5 is negative 3. So again, my solution works out. Moving on to a word problem, this says that Matt and Miki were the men's and women's hot dog eating champions. To make it interesting in the final competition, Matt will not start eating until Miki has eaten 20 hot dogs. They will eat at the same rate or speed that they ate before. So based on the number of hot dogs eaten in 10 minutes, how many minutes after Matt starts eating will they have eaten the same number of hot dogs? So looking at that scoreboard, it showed that Matt ate 62 hot dogs in 10 minutes. So to find his rate, I could divide, and I would find that I would be left with 6.2 hot dogs per minute. So that is his average rate, okay? That's pretty fast, right? 6 hot dogs in a minute. For Miki, if I do the same thing, I find that she ate 38 hot dogs in 10 minutes. And then when I simplify that, I get 3.8 hot dogs per minute. So why don't we now set up our equation so that we can figure out how many minutes it's taken for Matt and Miki to have eaten the same number of hot dogs. So Matt's rate is 6.2 hot dogs per minute. So I'm going to say times M, the number of minutes that it's taken. Likewise, for Miki, she is 3.8 M plus those additional 20 hot dogs. All right, so now I have my equation. Let's go ahead and solve it. Let's subtract 3.8 M on both sides of my equation. All right, this goes ahead and leaves me with 2.4 M is equal to 20. I'm going to divide both sides of my equation by 2.4. And I find that the number of minutes would be about 8.3, so 8 1/3 minutes, and that's when they would have eaten the same amount of hot dogs. And there we go. All right, let's move on to a couple more problems. This time I have two diagrams, and I'm trying to find x so that the rectangle and the triangle have the same area. So let's just review. The area of a rectangle is length times width, and the area of a triangle is 1/2 base times height. So let's plug in what we know. The length is x plus 4, and the width is 5, and that's going to be equal to the triangle, 1/2 times 12 times 2x minus 6. Let's use the distributive property. 5 times x is 5x. 5 times 4 is 20. Let's see, half of 12 is 6. Using the distributive property, that's 12x minus 36. And then I can go ahead and move my variables to the same side. So I'm left with negative 7x plus 20 is equal to negative 36. I can subtract 20 from both sides. And then I'm left with negative 7x is equal to negative 56. And when I divide both sides by negative 7, I find that the value of x is 8. And that's it. All right, let's move on. Find x so that they have the same perimeter. So this time I want the perimeter of a triangle, which is just adding up all three sides, to be equal to the perimeter of a square, which is just 4 times the side length. So now we can go ahead and write these out. X plus 6 plus 4 is equal to 4 times the side length, which is x plus 1. Okay, let's combine some like terms. I have 2x plus 10 is equal to, using the distributive property, 4x plus 4. Let's subtract 4x on both sides to move my variables to the same side. I have negative 2x plus 10 is equal to 4. And now I can subtract 10 on both sides to move it away from the variable. I have negative 2x is equal to negative 6. And when I divide both sides by negative 2, I find that x is equal to 3. And now I'm done. All right, I have two final problems for us. Let's go ahead and solve these. So again, let's get rid of the parentheses by using the distributive property. So 6 times y is 6y. And then 6 times negative 5 is negative 30. And then on the other side, 2 times 10 is 20. And 2 times 3y is 6y. Let's go ahead and subtract 6y on both sides. And, I have no more variables. All that I have left is negative 30 is equal to 20, which is not true. So when this happens, we are going to write no solution. There is not a solution for this equation, so there's obviously nothing to check. So if you eliminate your variables, it's going to be no solution. All right, let's do our final example. Let's use the distributive property to get rid of these parentheses. So that's 5x minus 5. All right. And now I'm going to combine some like terms. So 7x plus 5x is 12x. And I still have the minus 5 there. And look at that. It's equal to 12x minus 5. I can go further. I can subtract 12x on both sides, which get rid of the variables. But now I'm left with a true statement, negative 5 equals negative 5. If I go further and I add 5 to both sides, it turns into 0 equals 0, which again is another true statement. So if this is the case, we are going to say infinitely many solutions, which means there are just endless possibilities of numbers that you could plug in and the equation would work. Like I could plug in -15 or 0.5, but let's just pick any number then. So I'm going to pick the number 1 for my check just to see if it works. So 7 times 1 plus 5 times 1 minus 1, is that equal to 12 times 1 minus 5? Well, that's 7 plus 0, which is equal to 12 minus 5, which is also 7. So it did work out. So to wrap it up, I have 3 problems for you to try on your own. Please go ahead and try these, and we'll check them when we come into class.